All right, guys, so here we're going to take a look at the application. We're just going to kind of start a new unit today, right? We're going to take a look at the applications of derivatives, right? And hopefully we're going to start to get better pictures of what graphs look like, or at least use the idea of the derivative to help us identify maximum and minimum values, okay? And we're going to, what's cool about this is you guys see, you know the words maximum and minimum from your math career, right? And looking at optimization problems from grade 10, right? Where we would, complete the square. We don't need to complete the square anymore, which is nice, okay? We can find the derivative and set that equal to 0 and find these maximum and minimum values, right? That's what we're going to do, a whole bunch of optimization word problems again on Monday. And you guys are going to see these, and they're much nicer now with the derivative. We don't have to complete the square, okay? But first, we want to talk about, on a specific interval, right? What are the maximum and minimum values on a specific interval, right? So you'll see here, -4 and 0 would be our interval here, right? So if I'm looking at this little algorithm up here, this is pretty handy in terms of identifying how to navigate these questions, I suppose, right? We're just trying to identify maximum and minimum values on an interval, right? So we can say all points on the interval, right? So we want to, if we have a function f of x, and we know that it has a derivative, right? And every point on the interval, all points at the interval, we want to find where the derivative is equal to 0. This is going to be where our max and mins are, right? Right, you could have 2, you could have 3, you could have 1, right? Depending on the original function, right? And then the endpoints, you can plug in what the endpoints are and find what the actual values are at those endpoints, right? And so this is a good little stepping tool here to help you with actually doing these questions. So if we jump down and take a look at this first example, so this is finding maximum and minimum values for this function. Okay, it's just a quadratic on the interval, specifically -4 through 0, okay, for x values. And what you'll see is we want to find the derivative first. Okay, so let's derive this f of x function, right? We're going to derive it, so we're going to say, okay, well, the derivative here is going to equal -4x minus 12. Okay, now the first part here is just says, set the derivative equal to 0, right? This is going to identify, in doing this, we're going to identify the point or points in which we reach a maximum or minimum on our graph, right? So we're going to say 0 equals -4x minus 12. Now you'll notice right off the top, because this is a quadratic and we've derived, and I only see one x variable there, so I'm only going to get one max or min for this particular question, right? So 0 equals that. So if I bring the 12 over, I get -4x. And so my x value here is going to equal -3. So I know that there's a maximum or a minimum occurring at x equals -3. Your question then is, which one is it, obviously, right? Well, let's follow the steps here, okay? I know I'm going to follow the interval. I'm going to plug in -4 into my function. I'm going to plug in -3, and I'm going to plug in 0, okay? And I'm just going to try and produce the graph. Okay, so let's plot our points. So I just want to evaluate the function at -4, right? For instance, and then -3, and then 0. We just need to be -0. Okay, so that's all we're doing. Okay, so we're going to plug in the points, and when you do that, you're going to see you're going to get 6 when x is -4. You're going to get 8 when x is equal to -3, and then you're going to get -10 when x is equal to 0. Okay, so we can go on to our graph now. We go plot those points. -4 and 6 is right there. Then we can go -3 and 8. -3 and 8 is here, right? And then 0 and -10 is going to be way down here. So we know generally our graph kind of looks like this. And we also know something else, right? Just from 3 points, it's kind of cool to be able to produce this graph. We know that there's an axis of symmetry here, right? It's not a vertical asymptote. Don't confuse it with that. This is the axis of symmetry, which would equal x equals -3, right? We know that because that's, you know, the tangent line is 0 here, right? So we know in that, that's an axis of symmetry. I better expect to see a point here as well. Okay, and that can help you with this, okay? So now you can produce this graph. And you can draw the point because it's on your interval, right? So here's your graph, right? And it doesn't continue. We don't draw arrowheads because it's specifically on the interval of -4 to 0. And that's what I've drawn, right? So only from -4 to 0 is the only interval that I really care about for this. Okay, so all the values in that interval. Okay, now just identify, after you've drawn the graph or plotted the points, you can now identify, okay, with the fact that, okay, when I have -3 and 8, that's a max, right? You can see that's a maximum. Okay, but there is also, like, in this situation, you know, f of x has a minimum as well, right? It's right here. On this specific interval, we have a minimum in there as well, right? A minimum y value that it takes, right? So we can say, you know, the maximum along this interval specifically, right? Obviously, if we made the interval a little bit bigger, then the graph would come down here a little bit more, and we'd have a lower minimum, right? But along this interval specifically, we have a max of 8 when x equals -3, and a minimum okay, and that's it, guys. We just want to be able to try and start putting the idea of a derivative and using that idea to help us produce graphs. Okay, can you imagine like one of these questions from before, where we would have to factor that went pretty quick, actually, relatively speaking. If you thought about the grade 10 way to produce that graph, right? We'd have to factor, plot the roots, find the middle of the roots, find the which would be the axis of symmetry, and then we'd have to find the maximum value or minimum value by plugging that axis of symmetry back into the equation, right? It's a lot more work. This looks very easy, right? Here's an interval that we care about, you know, derive it. We know that's where the maximum occurs or minimum. And then, you know, just use some other background knowledge. That went pretty quick relative to a past way of doing these questions. Okay, so we're going to jump down here. You know, the only thing that I think we can really kick into make it harder is the fact, just, you know, how complicated is this function? How many minimums or maximum points are we going to have? Well, I suppose you only have one of each, but I'm more thinking along the lines of, you know, how many x's are you going to solve for here? You know, how many like what's your tangent line look like, or tangent function look like, I suppose is my point there. Okay, so we're going to find the maximum and minimum values of this function, right, for that specific interval again. Okay, and then we're going to illustrate our results graphically. Okay, so we're just going to do the exact same thing. Derive, set it to 0, right? Plug in all the points, produce the graph. That's it. Okay, that's what we're going to do. And we're gonna get a very clear idea right away as to what this graph looks like. And if this was a word problem, we could have an idea, right? Like a perfect example is down here. We could put the graph into context, right? So let's go ahead and do this. Okay, so first things first, let's derive this function. F prime of x is going to equal 3x squared minus 12x. Okay, and then we could factor a 3x out, and we're going to be left with x minus 4. Okay, now it says set this equal to 0, so 0 equals 3x times x minus 4. And so we could have two possible values that satisfy this expression, right? X could equal 0, x could equal 4, right? You guys would have seen this on your, in the if we were doing, and we're going to do more of this obviously, but in this morning's like investigation, you guys would have seen, okay, here's your interval, from -1 to 0, right? And then from 0 to 4, and then from 4 to 7, and you guys checked, or you would have checked, what is the graph positive or negative along the interval, like for 3x and for x minus 4. And then you'd figure out, positive or negative is the graph. Okay, this would be like an example. We're going to do more of this, but anyway, this is all tied into the graphing aspect of what we're doing here. Okay, this is just an introduction. So we can find, here are two special points, right? And we have two other special points, the interval. So we can say, okay, well, I'm going to plug in -1, I'm going to plug in 0, I'm going to plug in 4, and I'm going to plug in 7. Okay, and we know the 2 in the middle are the special ones. Something important's happening there, right? Or should be. Okay, so we can say, okay, let's what are the values after I plug these in, right? So I'm going to take the x values and I'm going to plug them into the original function and see what I get out. Well, when I do that, -1 comes out to be -11, 0 comes out to be -4, 4 comes out to be -36, and 7 becomes 45. Okay, so then I can jump over to my graph, right? And we can plot these things, right? Well, -1, this is going to be a very, very crude sketch, right? Like each one of these might be 10. Okay, so I'm going to plot and maybe 1s on this axis. Very crude. Okay, or sorry, count by 2s. Okay, this is like it's an informative sketch, if you will. Like, it doesn't need to be perfect, but you get an idea, right? So -1 and 11 is going to be here. Maybe I'll do this in different colors just to distinguish it. Okay, and then 0, -4 is going to be somewhere in here, and then we're going to go 4 and -36 might be all the way down here, and then 7 and 45 will be way up here somewhere. 10, 20, 30, 45, and 7 up here somewhere. Okay, so we can connect this. Again, we're only interested in this interval. Let me just see if I can get that a little cleaner. Okay, that's the interval we care about, and so we can identify, here, right here, look, we can see, at 0, we can see where our slope is equals 0, right? That's what we did, right? Where our tangent line is horizontal, if you will. And then we could say, okay, well, let's identify where the maximum and minimum values are. Well, this is a minimum, right? Which value is that? Well, the minimum value looks like here. This is a minimum. But then we also have this other value up here, right? This isn't a maximum because the y value isn't the biggest on this interval, right? This is the biggest y value on this interval. If we had stopped maybe here, on, I don't know, at x equals maybe, I don't know, if x equals maybe 4 or 5, right? Then yes, this would have been a max, but it's not. We didn't stop. We set our interval a little bit bigger. This is our maximum down here. Okay, so it doesn't have to necessarily be the turning points of the graph, right? At the or where the tangent line is horizontal. It doesn't necessarily need to be there. It's all dependent on what the interval is that's defined, right? So we could say, okay, well, min value, we'll say max value first, I guess. Max value for f of x is 45, and min value is negative 36. Okay. So again, what we're trying to do here, like if and this last question is going to be great for in terms of context, right? You know, we can produce graphs for virtually anything, right? Any function. And this is what we're trying to do here, is to get add an extra layer of understanding on math, right? And the situation, right? And so that's what the graph does. So we want kind of have an effective, quick way to produce a particular graph, right, for a particular situation. And I think finding the derivative and the tangent line being 0 is a great way to do this, right? And we discussed here how long this would take, right, to do it in a different way. So anyway, that's where we're at. I'm going to hit stop there, and then I'm going to do example 3 in a separate video. Okay.